we are going to solve one numerical problem, means we are going to find out the derivative numerically at initial point, at last point. So, without now, in order to save the time, here already we write the example. So, what is the question? Question is a find first two derivative. Find first two derivative at x equal to 50 and x equal to 54. At x equal 54 from the following data. From the following data. What is the data? At x equal 50, the value is a 3.6840. At 51, the value is a 3.7084. At 52, 3.7325, 53, 3.7563, and at 54, 3.7798. So, if we closely observe the question is a find the derivative at x equal to 50 and at x equal 54. 50 is the first value. 50 is a first value and 54 is a what? 54 is a last value. Means we are going to use the forward interpolation formula in order to find out the first two derivative at x equal to 50, and we use the backward interpolation formula of a derivative in order to find out the first two derivative at x equal 54. At x equal 54. So, what are the formulae? We know that as earlier we derived the formula of a derivative for what? For using the forward interpolation formula and using the backward interpolation formula. So, here directly we write a formula of a derivative using forward difference operator and backward difference operator. So, what is the formula? Formula is a what? Formula is a f dash x equal. So, here we write what? Here we write, we know that y dash equal f dash x0 equal 1 upon h del y0 minus 1 by 2 del 2y0 plus 1 by 3 del 3y0 and so on, and y double dash at x equal x0 f double dash x0 equal 1 upon h square del 2 y0 minus del 3 y0 and so on. Now, what is the value of a h and how we find the value of a del y0, del 2 y0, del 3 y0. So, in order to find out the value of a del y0, del 2 y0, del 3 y0, there is a need of a difference table. So, in order to save the time, already here we construct the what? Here we construct the difference table. Here this one is a forward difference table. Here we write the values of a x, here we write the values of a y. So, difference of these two 3.7084 minus 3.6840. So, 4 minus 0, this one is a 4, 8 minus 4 with a 4, and this one is a 10 minus 8, this will with a 0, 6 minus 6, this with the 0. In a similar manner, 5 minus 4 with a 1, 12 minus 8 with a 4, and 2 minus 0 with a 2. So, this one is a 0.024. In a similar manner, if we try to find out the difference of these two. So, this one is a 13 minus 5, this one is a 0.0, here this one become 7, not a 7, basically 8, because this one is a what? 7, 6, this one is 13 minus 5. Okay. So, this become 5 minus 2, 5 minus 2, this become 3, 3 and this one is a 2. So 0.0238, this one is the difference, and similarly difference is a 0.0235. 8 minus 3, 9 minus 6 and 7 minus 5, 7 minus 7. So this one is a difference. This one is a first order forward difference. Similarly, del 2y is the difference of these two minus 0.00, how many zeros? 303, and difference of these two minus 0.0003, and difference of this one is a minus 0.0003, minus 0.003. So del 3y with a what? Del 3y with a 0, 0 means the data given is the what? Third order difference, second order difference with a constant. So this one is a polynomial of a degree 2, because third order difference is a 0. As we know that the polynomial of a nth difference of a nth degree polynomial is a constant, and n plus 1 difference is a 0. So here n plus 1 third difference is a 0. So this data satisfy a polynomial of degree 2. So now what is the value for del y0? As we know that this one is a what? This one is a value for y0, this one is a value for y0, this one is a value for del y0, this one is a value for del 2y0, and this is the value for del 3y0, Now we put these values here, then we find a what? We find the values of a y dash x. So what is the value for y dash? Now y dash f dash at x equal what? At x equal 50. At x equal 50, this become what? 1 upon h, h be the 51 minus 50, h be the 1, because the class interval between each data 50 to 51, difference is a 51 minus 50. So h is a what? 1. So 1 upon 1. From here we put the value for del y0. So what is the value for del y0? The value for del y0 is a 0.0244. 0.0244. This one is the value for del y0 minus 1 by 2. 1 by 2. What is the value for del 2y0? Del 2y0 is a what? Minus 0.0003. So here we put the value for minus 0.0003. This one, and del 3y0 be the 0 and all other term be the 0. So all other term be the 0. So we simplify this result, then be able to find out the value for y dash. Y dash equal f dash 50. F dash 50. This one equal 1, and here from 0.0244, and 1 by 2 minus minus become plus 0.00015. So if we add these terms, so this become what? This become 0.0202455, because this one 0.02424 and this 4 plus 1 5 and 0.02455. So this one is the value of f dash 50. F dash 50. Similarly, we try to find out a second order derivative at this point. Then what is the f double dash 50? Now f double dash again, f double dash 50 become what? F double dash 50 become 1 upon h square del 2y0 minus del 3y0 and so on. Since del 3y0 and so on, all other difference, all other order difference with the 0. So what is the value? Value become h with the 1 upon 1 square with the 1 del 2 y0 with the what? Del 2 y0 with the minus 0.0003. So this one is a what? This one is a value of second order derivative at x equal 50 minus 0.003. This one is a, once we verify the result, so this one is a, I think this one is a correct one. 2455. Okay. This one is a derivative at x equal x0. And similarly, in order to find out the derivative at x equal 54, then we what? Then we write a formula for the backward difference operator. So what will happen here? Here we write a formula for the backward difference operator. So y dash equal f dash xn equal what? Del n, sorry, not a del n, del yn plus 1 by 2 del 2 yn, and here plus 1 by 3 del 3 yn, and so on, and y double dash become f double dash at xn equal what? This become del 2 yn plus del 3 yn. Now we put the values of from this difference table. So what is the values here? As we know that this one is a value, this one is treated as a yn. Also you may say this one is a y1, this one is a y2, this one is a y3, this one is a y4. So this one is a what? This one is a, in case of a backward difference operator, this one is a what? This one is a del y4, and this one is a what? This one is a del 2 y4. As we know that the difference table will be the same, remains unchanged, but the notation become changed if we consider it a difference table as a forward difference table or backward difference table or central difference table. So we are going to use the value of del y4 and del 2 y4 here. So what is the value? Value become what? Here we are going to use these two values. So y dash become what? Y dash become y dash at f dash 54 at the end, because 54 with the xn. So what is the value for del? Here we write a del y4 plus 1 by 2 del 2 y4, and there is no need to write all other term, because all other term with the 0. All other order differences with the 0. So what is the value? The value become del y4 with the 0.0235 plus 1 by 2, this become minus 0.0003. So this one is a what? If we simplify this one, this one, okay. So this become what? 0.0235 minus 0.00015. So if we subtract this one from this one is a 0 to 3, this one is a 50, so 50, or so this becomes 35. So this becomes 0.023, and 50 minus 15, 35. So this one is the result. So once we verify this result, I think this one is a correct result. So this one is the answer. And what is the f double dash? Similarly, y double dash equal f double dash 54 equal what? Del 2 yn means del 2 y4 plus del 3 y4 because del 3 y4 with a 0, del 3 y4 with a 0 and del 2 y4 with a what? Del 2 y4 with a minus 0.0003. 003. So 1 upon h here I have not written the 1 by h, basically this one is a 1 upon h, this one is a 1 upon h square, since the value of h is a 1, so there is no any effect on a answer. So this become 1 upon 1, so this become 1 upon 1, this become 1 upon 1, this become 1 upon 1, so this become answer. So what is the answer? Second derivative at x equal to 54, this one is the answer. First derivative at x equal to 54, this one is the answer. This one is the answer. And first derivative at x equal to 50, this one is the answer. And second derivative at x equal to 50, then this one is the answer. So this one is the answer. So once we verify these results, so this one is the answer and this one is the answer. So this one is a way how we find a solution if we try to find out a derivative at a initial point. Suppose if we try to find out a derivative at x equal to 51, then again we use the forward interpolation formula, but we doesn't use this formula, we use the formula in term of a u. We use this formula. So we use this formula of a second derivative. Similarly for the first derivative we use this formula in term of a u. Okay.